This is 5.3, number 53. So determine whether the following statements are true and give an example or explanation or counterexample. F is a constant function from A to B. We can do that. F is a constant function. A constant function is a horizontal line from A to B. It says then the right hand and left hand sums gives the exact value. So let's do just 3 intervals, 3 subintervals. There's our 3 rectangles. If I do a left hand Riemann, I go up the left side till I touch, come over, go down. Then I do one from the next interval, and you will see that there is no error. That these 3 rectangles is the area underneath the blue curve from there to there. So that's true, whether I go up the left side or whether I go up the right side. So that's going to be true. B, if f is a linear function from A to B, this is a great question. Do you understand what this is saying? So you have a linear function from A to B. It doesn't have to be a line with a slope. It could be a horizontal line, but it doesn't matter. There's a linear function. Then a midpoint Riemann sums gives the exact value. So again, I will do 3 intervals. I already have them marked out. The midpoint, you go up the middle and you make your rectangle. You go up the middle, you make your rectangle. And you go up the middle and you make your rectangle. So because this is a straight line, right there we have, I'll do a different color for you guys. We have extra. That's extra area. But we're missing area there. Those will be exactly the same because you have a straight line. This is a triangle and that's a triangle and they're the same triangle. So the amount you have extra, let me go ahead and shade this. Oh, it's gonna be too fat, huh? Yeah. So this is the area of the first one. This is the area of the second one. And then the third one. I'm not gonna do it perfectly. Yeah, that's beautiful. So you will notice with this, there's extra. That shouldn't be there, but you're missing a chunk and those are the same. Then you have extra that shouldn't be there, but you're missing a chunk and that's the same. And you have extra, but you're missing a chunk. And all the extra and missing chunks are the same amount, so it balances out. That's why this is true. A midpoint gives you the exact value when you have a straight line. All right, part C. What does part C say? You integrate the sine function from A to 2 pi over A, and you integrate the cosine function from 0 to 2 pi over A. Do those both equal 0? So it's going to be true, and it's going to be the nature of the graph. So let me show you. I'm going to do both the sine and the cosine. I'm just going to explain to you. So we're going to go the sine function. What does it look like? The sine function looks like not like that. Right? And it goes on forever. Well, it wants me to integrate starting at 0 and end at 2 pi over A. Now here's the deal, if you remember from trig. From trig, the period of a sine function is 2 pi over that. So what it's saying is, this is 1 period. The 2 pi over A, that's 1 period. So I'm going to go from there, and this will be 2 pi over A. And so if you integrate that, that's the net area. But if you look, the area of this piece minus the area of this piece, well, if I drew it right, those will be the same. So you're going to have a positive amount subtract a negative amount. They will cancel each other out. So therefore, that net area will be 0. And for the cosine function, let me draw. I'll go ahead and do this. You know how I'm going to do the cosine function? Check this out. I'm pretty smart. Now it's a cosine function because the cosine starts at 1. Let me erase that. Okay, 1 period of the cosine function. So we're doing the same thing. We're going from 0 to 2 pi over a, but the period of that function is 2 pi over a. So 1 period will be right there. That's 2 pi over a. Now what's going on in this case, if I color these in, I have that piece, and down below, I have that piece. But that and that make a whole hump. So you add a whole hump, you subtract a hump, and you get 0. So that's why you're going to get 0 for that. Okay, let's keep going. We have 2 more to go, but these are really good questions. Integral from a to b is equal to integral from b to a, then f is a constant function. I'll show you why that's false. I got to give you a counterexample, don't I? Counterexample. So they're saying if you have a constant function, could be positive or negative, I'll just make it that. And you have a and b. And you're integrating from a to b of f of x. That's going to be the area of that rectangle, net area. And it's positive because it's above. But then this says you go backwards. You learned if you integrate backwards, you get the opposite answer. So you're actually going to get negative. It's going to be negative that area. So they're not the same. The area going forwards is positive, but when you go backwards, your answer is going to be opposite. So this would actually be, they will be opposites of each other. You should have a minus there. So that is false. Now there is one constant function where it's true. I don't know if you guys can think of it. Anyone know what it is? If you said y equals 0, if you do that, what's the integral from a to b? 0. What if you go backwards? It's still 0. So that's one case, but it has to work for all constant functions. So that's a false statement. And E, property 4 from table 5.6 implies what? Okay, no. This is a liar, liar, pants on fire. Because property 4 says if you have a constant, you can pull it out in front. X is not a constant, that is your variable. So false, false, liar, liar, pants on fire. And as a reminder, Yoshida, edit this video before you post it.